Tennis balls are sold in cylindrical cans with the balls stacked one on top of the other. A tennis ball has a diameter of 40.5 centimeters. To the nearest cubic centimeters, what is the minimum volume of can that holds a stack of 5 tennis balls? So let me draw first this can. It will be something like this. Cylindrical can. What we know that we can put to the cylindrical can 5 tennis balls, and we know that tennis ball has diameter 4 centimeters. So the diameter is D is equal 4.5 centimeters. The radius or the base will be half of diameter, so we can write that R is equal 1/2 of D, so this is 1/2 of 4.5. Let's forget about units right now. So this is equal 2.25. We have radius of base of our can, cylindrical can, and the height h will be, because we have to find the minimum value of the can that holds a stack of 5 tennis balls. One tennis ball has diameter 4.5, so we have 5 tennis balls, so it will be 5 times diameter D. The height will be 5 times 4.5. So this is equal 22.5 centimeters. The value is area of base. The base is circle, and the area of circle is pi r square times height. The value is base times height. R we calculate is 2.25. H we calculate is 22.5, so we can substitute to this formula. Pi we copy. R is 2.25 to second power times height. Height is 22.5. So now we can use calculator. We have pi times, open parenthesis, 2.25 to second power times 22.5. This is equal 37.84, because we have to find the value to the nearest cubic centimeter. So we have to check the digits after decimal point. So we copy digits before decimal point is 3, 5, 7, and one digit after decimal point is 8. And now, because we need to find the value to the nearest cubic centimeter, we have to round this number to the unit. So it will be, after 7 we have 8, so we need to add 1 to the underlined digits. So it will be approximately 3, 5, 8, and the unit is cubic centimeter. This is my solution.